Hey guys, it's Mrs. Dugan. So today we are going to talk about plate tectonics. All right. So the last couple times that we've talked, we talked about the rock cycle. We've talked about different types of rocks and what that means and how they are recycled through the actual rocks cycle. So we're going to move on. So we just talked about the Earth's layers. Now for us, the four layers of the Earth are the crust, which is the top, and that's where the continents are, that's where land is, that's where water is, that's where fossils are. Okay, and then we have underneath the crust is the mantle, and this is where the convection currents are, and that's where the core is heating up the rock in the mantle. It's rising, this hot rock rises, and then as it cools it falls back down, and it creates this wheel effect for that are going to move the plates, the tectonic plates. Excuse me. Underneath the mantle, we have the outer core, and the outer core is going to be where our magnetic field is located, but not located, where it's generated. It's a fluid. The outer core is the only fluid level, and then we have our inner core, which spins faster than the actual Earth rotates, and it's going to be a solid ball of metal, which is mostly made out of iron and nickel. So anyway, plate tectonics. This is how the world is broken up. Okay? So first things first, where in the heck did this idea of plate tectonics come from? So it really started with this guy named Alfred Wegener. There's a nice little cartoon of him, and he proposed this idea of continental drift in the early 20th century. So what he did is, if you look at this picture, he's holding Africa and South America, and he was looking at this and he said, well, look at here, I see that these two kind of fit together like puzzle pieces. And so he kept looking at them, and he's looking, and he said ultimately that these continents were all one big connected continent. So he proposed that the continents had been joined or connected. Now, ultimately, Wegener wasn't really believed. It wasn't widely believed because he couldn't explain why these continents have moved. Okay, and it wasn't until later in the 20th century that his theory was really believed, and that was due to the theory of plate tectonics. So if we talk about the world, we have this new word which is called the lithosphere. And the lithosphere is the rigid outer shell of the planet. Now, I said that our model for 7th grade science at Avon Middle School South states that we have 4 layers. However, there are more in-depth models that say that there are more layers than just 4. This is going to dive into those more descriptive models a little bit more. So the lithosphere is actually going to be the crust and the upper mantle. So instead of just saying that we have a mantle, this model says that we have an upper mantle and a lower mantle. And the upper mantle and the crust make up this lithosphere. Okay, so this is the rigid outer shell. It's made of rocks. It's going to be broken up into tectonic plates. Okay, and these tectonic plates are just big sheets of rock that are going to move slowly over the lower mantle. So one thing that Wegener said is that, the continents moved. However, they're still actually moving. They're going to move at a rate of centimeters per year. And actually, scientists have said that it's about 2.4 centimeters per year that the plates are moving. And this is really specific to the mid-Atlantic tectonic plate boundary, okay? It's in the middle of the Atlantic Ocean, and they're saying that the Atlantic Ocean is spreading about 2.4 centimeters a year. So I measured it. 2.4 centimeters is about the size of my thumb. So the Atlantic Ocean is getting bigger and bigger by about this much every single year. So we're getting pushed away from Europe about this much every single year. And the Atlantic Ocean is getting bigger and bigger. So what does that really mean? Well, it means that we're getting closer and closer to Asia every single year. So it's really interesting. Now, Wegner said that this supercontinent existed. So this is when all of the continents were joined about 335 million years ago, and he coined the name Pangea. So Pangea, if we break it down, Pan or Pan means entire, okay, and Gea means land. So if we put it together, the root is entire land. So all of the land was once connected into this big supercontinent. So where in the world are these plate boundaries, or where are these plates? So you're going to see there are 8 major plates. Now, the one that's really common that at least us Americans know is this plate boundary over here, the Pacific plate. And this Pacific plate is really common because it runs right through California. And what happens in California a lot? Not only fires, but a lot of earthquakes. And that is because of this plate boundary right here. So the lithosphere, or remember, the lithosphere is made up of the crust and the upper mantle, is broken into 8 major plates and many minor ones. So when we talk about the minor ones, there's one right here down by Cuba. We have another one here. All right. So they're the big plates, like the South American plate, the North American plate, the Eurasia plate. Those are our big main ones. And then we have our little tiny ones that we see here. Okay. So, how do these actually move? Well, it's going to happen in the mantle. And this is all going back to our heat transfer unit. We talked about convection. So, convection is where we have the transfer of heat through fluids. Okay. Now, remember, fluids can be like air, they can be a liquid, anything like that. All right. So, the plates on Earth's surface are going to move because of what is called convection currents in the mantle. Now, when we talked about convection, we talked about a hot air balloon. So, what happens in a hot air balloon is that we have this heat source that is going to heat up the air, and the hot air is going to rise and it's going to fall back down, creating this cyclical effect or this cycle, right? This circle. That's exactly what happens in the mantle. So the earth is just kind of like a hot air balloon, except we're staying still. Okay. So the the hot rock is going to rise and the cooled material is going to sink back down towards the core. Okay. And this is really important because as it's pushing, it's just the wheels on the bus go round and round, round and round. Okay. But the only thing that's moving are the tectonic plates, not the wheels on the bus, not the bus, but the tectonic plates that sits on top of the lower mantle. Now, there are 3 types of plate boundaries. So we've talked about why the plates move, what the plates are, and what happens when these plates move. However, we need to talk about what happens at the boundary. Okay, this means when two plates meet, what happens. So there's 2 things that are going to happen. First, there's going to be some kind of phenomena. All right. Something's going to happen with the plates. Either they're going to come together, they're going to pull apart, or they're going to slide past each other. And when they do that, they are going to create some kind of phenomena like earthquakes, or they're going to create a landform like rift valleys, trenches, and all of that. So let's get into that. So convergent. If something is to converge, it means to come together. So if you take your 2 hands and you push your hands together, what does it create? It creates a mountain. So that's one landform that can be created with convergent plate boundaries, and that is a mountain. Okay. The other thing that can happen is if you think about a collision. Okay, think about a car. Let's pretend a semi and a car. What's going to happen? Well, the car is going to go underneath the semi. And that can happen also at convergent plate boundaries. So when it goes under like this, what happens is one is going to subduct under another, and it's going to go into magma and it's going to melt. So that allows for magma to come through and create a volcano. So you can have a mountain or you can have a volcano. And the last thing that it can create is called a trench. And a trench is a deep, deep hole, usually in the middle of the ocean, like 99% of the time in the middle of the ocean. And this is due to a convergent plate boundary where one is going to go under the other or go like this. Okay. So a convergent plate boundary is where two plates are moving towards each other. Okay. So plates can push up to form mountains, or one can sink below or slide below the other, which is called a subduction zone. Now, I want you to write this down because at that subduction zone, that's where volcanoes are created and where those trenches are created. Our next one is divergent. So here's where I used to get confused. I would think, okay, divergent. That means they're splitting apart. That means there's going to be this massive hole in the earth because they're splitting. That's not what happens. Okay. So a divergent boundary is where two plates are moving away from each other. We can see in the arrows they are moving away. Now, what's going to happen, what actually happens here is that we have, let me get my nice little thing. We've got magma that is going to rise up and fill this space. Okay. So this magma is going to fill in and it's going to cool. So what happens is that when this magma cools, new crust is actually formed when it rises. Now, the thing that's going to be created, the landform, you have two options. You have a rift valley, or you have what's it called? An oceanic ridge. Okay, so a rift valley is where these two plates are going to separate, and you're going to get this nice kind of rift here. Or what's going to happen is that they're going to go here, and the magma is going to rise up high and create this ridge, which is like a hill in the middle of the ocean. So the Atlantic, the Atlantic Mid-Atlantic Ridge is one of the most famous divergent plate boundaries. And that's because this actually gave some evidence for the for Pangea. Okay, so that ocean ridge is how we know that at one point we were connected, because it keeps growing and growing and growing. Okay. The other thing is that when lava and magma cool, they're going to create new sea floor. Okay, this usually happens at the sea floor. Okay, at least for the most part. Rift valleys can happen on land, but the most famous ones are usually in the ocean. Our last one that we're going to talk about today is a transform plate boundary. Transform plate boundaries are where plates slide sideways past each other, okay? And if you take your hands and you're rubbing them together, what does this create? What type of force does this create? It's friction. So what happens is, as these plates are moving next to each other, they're creating a lot of friction and a lot of pressure. And as that pressure builds, the only way that it is going to be released is through an earthquake. Okay. Now, the way that I like to think about transform boundaries is when you're going down the hallway, how many of you have shoulder checked someone? By accident, most of the time. Okay, so essentially, transform boundaries are just students going down hallways, shoulder checking themselves. And what's going to happen is that someone's going to get hurt because some fight is going to break out. So that is your transform boundary. Okay, so ultimately, what I want you to remember from this lesson is that there are three types of plate boundaries: convergent, divergent, and transform. Okay, each of those are going to create a distinct landform or phenomena. So convergent, we have mountains, volcanoes, or trenches. Okay. Divergent, we're going to have rift valleys or floor spreading, or what is also called the Atlantic Ridge or Oceanic Ridge. And then transform, which is the easiest because we're building a lot of friction, is going to be an earthquake. Okay. Last two things I need you to remember. Tectonic plates move from convection currents, okay? That is a very, very, very important thing. How do plates move? It's not that they just have a mind of their own. It's that they move because of convection currents. And those convection currents are located where? In the mantle, all right? So those are our notes for today. Please make sure that you review these and make sure you have them written down. Okay, these are very important things that will most definitely be on the test. So keep studying. Y'all have got this. And just remember, 3 plate boundaries. Have a great day.